Hey folks, welcome again to another edition of the online data engineering meetup. This is obviously the March edition because we're in March. That came along really fast, didn't it? 2022 is off to a flying start. And we've also got in-person meetups just around the corner. In fact, in Sydney, we've got an in-person meetup just next week down at the Microsoft Reactor. So that'll be really good fun. Other in-person things that are happening very soon is we've got a DataEng hack, a hackathon for data engineering. So it's brought to you by the DataEng Bytes conference team. That'll be happening here in Sydney. We've got limited tickets. They're $50 each, I believe, or thereabouts. You're going to get exposed to some amazing technology on the day. You'll be sort of forming teams of 5, and there's going to be some great prizes. Some of the hacks or challenges for the day is, building out a single view of customer, using a graph database, building out a real-time data app, which is all the rage these days. Another one is metadata extractors for databases, for use in a data catalog. And then finally, the fourth challenge is going to be building the most ridiculous Rube Goldberg data engineering pipeline. So just stringing together as many different data engineering technologies and services together to make, the most ridiculous Rube Goldberg data engineering pipeline. So I think it's going to be very informative. You're going to learn a whole bunch, and you're going to do some amazing networking on the day. So that's going to be really wonderful. So I'll post the link down the bottom in the chat for where you can sign up if you live in Sydney. And we'll be trying to bring that to other cities around Australia in the near future as well. So stay tuned for all of that. So that's happening on the 28th. Thursday, the 28th of April. Cool. So that's a bit of the announcements out of the way. I'm always fascinated to find out where you're dialing in from. I'm dialing in from near Georges River here in Sydney. It's a really lovely part, lots of wonderful parks and stuff like that. Love taking the kids for walks and stuff like that. So really keen to hear a bit about where you're dialing in from and how you've been going during all the lockdowns and the like, and sort of newfound freedoms that we're getting here in Australia. But I don't want to sort of take away from too much from our amazing speakers today. We've got 3 awesome speakers joining us for this meetup, and really sort of pleased to have them. So we've got Andy Hattemer. He's the head of DevEx Engineering at Materialize. He's subbing in for Marta. I think she had an unfortunate accident on her bicycle, and couldn't make it to us today. But she plans to join us in the near future. So really excited about all of that. So Andy will be taking us through sort of getting up and running with Materialize. So that's going to be fascinating because one of the hacks for DataEng hack is building a real-time data app. So that'll be really cool. Materialize ties in quite well with real-time streaming. And so our second talk for the day is going to be from Brett Randall. He's a Senior Solutions Engineer at Confluent, and he will be giving us a Data Mesh 101. So if this is your first time hearing about data mesh, or you're not super confident about what it is and how you can implement it in your company, I think it'll be really great to hear from Brett Randall about what that's all about. So that'll be fantastic. And then finally, our third talk for today is going to be another real-time data use case. So data analytics made easy, building a Twitter scale model analytics application in under 10 minutes, which just sounds amazing. And that'll be Will Zhu, product at Imply. So we've got 3 really cool cutting edge talks brought to you today. So strap yourselves in. We're about to bring on our first speaker for the day, Andy Hattemer. How's it going, Andy? Where are you dialing in from, by the way?
Hey, Peter. I'm coming in from New York City, so it's 9 p.m. here, but I'm excited to be here.
That sounds awesome. Well, really glad to have you here. Glad to get another Materialize talk. I think we had a talk from Jessica Lachlan at DataEng Bytes last year, and it sounds like a really amazing product. So yeah, if you wanted to share your slides and take it away.
All right, let me share my screen. And that by the way, that hack day with the Rube Goldberg data pipeline, I feel like that's what the type of data pipeline most of us are building anyway. So I don't, it might be more of the same, but I don't know if I'll make that. But so hi everyone, I'm Andy. Thanks Peter for the intro. So yeah, I hope you don't feel too bait and switched. Marta is also my favorite colleague, and she was supposed to be here, but she's doing fine. And regardless, I'm here, and excited to talk to you about Materialize. So I'm the head of DevEx here, and I have to admit that I've never worked as a data engineer. I have a pretty odd assortment of roles over the years that kind of revolve around being adjacent to data engineering. So I've worked as a developer building apps that are either pushing analytics or just acting as the source and pushing change data into pipelines and eventually warehouses. And I've also built the other side, product and marketing automation that relied on data from warehouses. And I've written my fair share of gnarly SQL that's probably set off some alerts and caused some fires for data engineers. But I'm not going to necessarily pitch you on Materialize. I'm just going to cover what Materialize is and how it's similar to certain tools and how it's different. So let's get right into it. Let's start with what's the same, and that's SQL. So everything that we're going to talk through and demo in this talk uses the same SQL that you know and have used since the beginning of time. And that means that if a statement like this makes sense to you, then you already know how to write SQL that runs on streaming data. And Materialize is built on this realization that I think there's a new wave of tools that are coming out to do this, where they've realized that SQL is a declarative language. It's just as good as defining a persistent transformation as it is at defining a point-in-time question. So there's nothing in this query that says, just give me the results for the exact time I execute the query. This could work equally well as a streaming transformation. So before I go any deeper, I'm going to take a step back and start from the kind of beginning to get everyone into a shared context. And that beginning is where almost everyone starts when they're building a company, is a single transactional database. So it's designed for high concurrency with lots of reads and lots of writes and transactions. And in general, it works very hard to make sure your business data is consistent and available. But because OLTP engines can answer any query, even analytical ones, people will often start running their analytical queries on the primary database. And this is honestly fine for a while. And maybe you use a read replica if you really want to be careful. But at some point, this stops being a good idea. I've done this. I've been there for this situation where maybe an internal analytics query overwhelms or locks the database and it breaks customer-facing applications that are depending on it. Or maybe it's just a matter of needing to join in other types of data. And that's naturally where we come to the kind of common pattern of data engineering pipelines where we're offloading things to a second database. And that one is built in a different way to be more friendly to analytics workloads. So an OLAP database where you don't have the same strict requirements for concurrency or availability. And these are great for complex queries, multi-way joins, subqueries, aggregations. It's a totally different set of things that it's optimizing for. So now you have these two separate systems, the transactional processor on one side, and that holds the source of truth for your data, and the analytical processor on the other, handling the complex queries. But now your customers and internal stakeholders have become more data literate, and they're asking for more. And so we run into a new set of problems with the ELT warehouse model. A few that I've talked to people a lot about are just the complexity and orchestration of batch loads and transforms is still tedious and fragile and slow to debug, especially as it changes. Also, now that people are starting to programmatically read from the warehouse with things like reverse ETL, where they're connecting systems like CRMs or Salesforce or ad networks or marketing tools to read from the warehouse, it's no longer when you're reading from a warehouse into a BI tool, the person can know that the data is 1 day out of date and factor that into their decisions. But when you start syncing it out to third-party tools, that knowledge is not always preserved, and suddenly the latency becomes more important. And then also another trend that we're seeing is user-facing views on the data warehouse, where some kind of data in the warehouse is surfaced to maybe it's a merchant or market vendor dashboard, but ultimately to your customers. And the warehouses weren't originally architected for this, and it often involves some Rube Goldberg-esque machines of shared BI dashboards, and it's not ideal. And that's where Materialize comes in, and this is how it's fundamentally different than both the OLTP and analytical databases. You can think of the traditional databases as poll-based, where the query engine will idle until it gets a select statement, and then it computes the answer and it returns the results for that point in time. And Materialize is push-based, where it asks for the queries upfront and then it incrementally computes the results as new data arrives. So it's maintaining the results of the SQL query as a Materialize view in memory as the data changes. So in practical terms, let's just go through what this looks like. So you start out by defining a query as a Materialize view. And what you're really telling the database is, I'm interested in asking this question over and over again, or knowing the answer to this question over and over again. Can you keep this up to date for me? And as data comes in, Materialize maps the SQL query to a data flow behind the scenes to calculate the result. And when new data arrives, the result is updated incrementally, and that continues to happen endlessly on a stream of events. So in short, Materialize is a database wrapped around a stream processor. It reads in streams of data, and often the data is coming from change feeds from databases, which is the CDC section here in this diagram, or change data capture. It can also take in things like web analytics events, logs, archive data in S3, really any kind of structured data. And then once the data is accessible to Materialize, you define your transformations just like you would in a warehouse like Snowflake, except instead of using commonly when you're using an ELT pattern in a warehouse, you might have views, which are essentially saved queries, or you might build a table from a query. Instead, in Materialize, you're creating materialized views, which are kind of a niche case outside of Materialize. They're views that are incrementally updated. So the Materialize engine figures out how to maintain those views, and each new event that comes in triggers a small amount of work to update the view. The other way that Materialize is like a database is when it comes to reading the data out. So I mentioned that so Materialize is Postgres compatible, where you can connect it to BI tools like Looker or Superset or Metabase. And when you're doing that, you're basically telling the tools, I'm connecting to a Postgres database, and you're putting in your Materialize credentials. And behind the scenes, Materialize is responding to the Postgres API and able to interact with this pretty broad set of tools that way. But because it's a stream processor under the hood, you can also skip the query part and sync data directly out of Materialize into a message broker like Kafka. And in that setup, the data is being pushed out of Materialize. And the events that are pushed to Kafka are the change events from the views that you've created. And you can also do something similar with libraries, Postgres libraries, and all of the standard or all the languages like Node.js and Python, where you can use Postgres transactions to subscribe to updates on a view to create some really interesting reactive applications. So let's see Materialize in action. I'm going to do a little bit of a live demo here, but before I get into that, I just want to go through the architecture. So in this demo architecture, we've got, it's kind of a contrived e-commerce example where we've got a MySQL database with some tables like users, purchases, and items, and that's changing over time. And then we have page views being generated directly into Kafka, or in this case, Redpanda. And Debezium is a service, if you're not familiar with it, it's a change data capture service that listens to the replication log, or in MySQL, the bin log of the database for creates, updates, deletes, and it turns those into events into Kafka. So all of the data is streamed into Kafka. Materialize connects to Kafka, reads the data in, and runs the SQL transformations. And we are able to query those downstream. In this example, we're demonstrating using Metabase. Okay, so I'm going to switch over to my tabs here. So the first step when it's basically configuring Materialize, we're creating what's called sources, which are telling Materialize where to look in the upstream data services for these events. So we're going to create a source for our page views and a source for our purchases. And the syntax here, as you can see, it's telling it where the broker address is. It's telling it the topic name, and it's telling it a little bit about the format, which is a little different for these two different types of events. So let me switch over. And the first thing, so I'll share the GitHub repo of the demo code that I go through after this. I've got it all Dockerized, but one of the first things I wanted to show is just the way that you're connecting to interact with Materialize and execute any kind of DDL or select statements is just via Postgres. So in this case, we can use the pSQL command line interface to connect in, and we can write those create source, or I guess you would call them DDL statements, to tell Materialize where to look for the data that we're working with. And then now I can write show sources, and we can see we've actually got the purchases source, the page view source, and we got items and users in there as well. And next, I'm going to show a couple of the key concepts in Materialize where one of the things that works exactly the same as something like Snowflake is that users are often stacking views to create their transformations. So if you're familiar with the ELT setup, where you might use something like dbt to do the transformations of your raw data into staging tables and then marts, you can do the exact same type of thing in Materialize. So as an example, I will create a, actually I'll pull it from here just to show you. So I will create a regular view, and this is the normal way that you create a view that can be queried as a Materialize view. When you're creating a regular view, it's just like a data warehouse where it's essentially a saved query. So I'm going to create that. And what it's doing is taking the raw JSON and casting it into a format that's a little bit more usable for other queries. And it's also doing some extraction of URL paths to give us a little bit more usable data. So I'm going to create that. I can write show views, and you'll see that the view's been created, but still no data has been pulled into Materialize because nothing's been materialized. So that's where I'm going to start with my first Materialize view is going to be, actually I'll do this page views by item just to show you. Okay, so now I've executed this. Materialize is going and creating a data flow to be able to maintain the results of this query. And then it's going to its Kafka source, in this case, the page view source, the page view source, and pulling in all of the events and running them through that data flow so that I can write something like select star from page views by item, put it at a limit, and can see the results. And I can also see the results changing over time because every event, every new page view that's created gets processed through the data flow and updates the view. But let me just create a couple more views where I'm going to show that's basically just an aggregation on one table. But where it gets a lot more useful is when you start doing joins and aggregations on multiple tables and different types of data. So in this last example here, I'm creating a summary table where I am joining in the items from the MySQL database, the purchases, which are already aggregated in a different table, and the page views that are coming just directly from logs in Kafka. And so I can create that, and then what I'm actually calculating in this query is things like the revenue, and then also something, this is a little contrived, but the conversion rate, where I'm taking the page views on the item page and the orders of that item and calculating a conversion rate. So I can say select star and I can start to see these results, and they're actually updating over time. And a little hack just to show, most databases and clients are not used to encouraging people to hammer the database with repeated queries. But in the case of Materialize, that's perfectly fine because the results are maintained in memory. So you can run a, let me just show what I was running here. You can run, just repeatedly run the query every second and see that the results are being updated as data is emerging in or updating in MySQL or being written to Kafka and then getting processed through Materialize. And then lastly, let's see. Well, I don't want to take up too much more time, so I won't show the Metabase connection, but essentially what you're able to do when you're querying data or connecting downstream systems to Materialize is just connect as if it were Postgres. And it's often, again, it's not often that these tools will tell you, oh yeah, just run the query over and over again. They are also trying to reduce load on the warehouses, so they're often trying to cache queries. But in the case of connecting Materialize, it's fine to just run the queries whenever the dashboard loads. You can have many clients connecting. There's no limits to concurrency or things like that. And so there's a lot more data application type of use cases that you can do with it. So just to wrap up, the TLDRs, Materialize lets you build streaming applications using SQL, and it takes care of the heavy lifting for you. So you can ingest from a range of sources, query in standard SQL, and you get the incremental view updates. And because it's Postgres compatible, you're connecting to, or you have a built-in set of very mature tools that are meant to connect to Postgres that can read and query from Materialize. So I hope that was interesting, and I would love for everyone to try it out. Join us in our Slack community if you have any questions, and I will share in the DataEng Slack, I'll share a link to the GitHub demo code that I went through.
That's awesome. Round of applause, virtual round of applause for you, Andy. Thank you so much. Yeah, very good substitution for Marta, so thank you. Well done, especially at such short notice. We've got a couple of questions coming through on the live stream from YouTube. Abhinav Goyal asked, I noticed the Debezium in there. Is that what you were using under the hood?
Yeah, so that's an interesting. Debezium is upstream of Materialize. So going back to the architecture here, Debezium is a really great way of getting data from transactional databases ready for Materialize. Because if you think about it, if you're building this database that it's basically working on the writes instead of the reads, it needs a big bucket of writes, and Debezium is essentially doing that, where it's taking all of the change events and streaming them into Kafka. So a lot of our users use it with Debezium, where it's separate from Materialize. Materialize doesn't have any like Kafka or Debezium service within it. It's purely the engine.
Awesome. A question from Will Zhu, he's product at Imply, so probably a competitor, but he's asked, when I run a query against Materialize, does it fuse live data with what's been materialized already? Pardon the pun, I'm guessing. Or is it, or it only shows me the data that's been materialized already? So
I think I understand this, but you might have to clarify. But what Materialize is doing under the hood is just maintaining the minimum amount of state necessary to continue to answer these questions. So here's an example that's interesting to think about. Imagine you have like an attribution model where you're joining a big set of page views to a set of users that are signing up in order to do some kind of attribution. Because if you were to write that join, Materialize, because you can have a user created at any point in the future, that will need to join into the corresponding page views, Materialize would have to keep all of the page views in memory. And so there are certain things like that where you have to, it's not an ideal case for that situation. So there's like, when it comes to wanting to query years of historic data, a data warehouse is probably going to be better. But where it does a lot better is any kind of fast changing data. And in that case, it's just, it knows based on the query how much state it needs to maintain, and it does that.
Thanks so much for the answer. Jose said, awesome prezzo, Andy, so well done. And Abhinav was very thankful for your answer as well. And then we just have one last question before we'll hand over to Brett. But so what are its, so with Materialize, what are its storage or volume limitations it can handle?
Yeah, that's another interesting one where, so it's all in memory, and Kafka would be the source of truth in this architecture that we're looking at right now. And so you might enable Kafka compaction, or you might offload data to S3 and join it back into Materialize that way. And what's interesting is what we found is it scares people at first. They're like, well, if it's all in memory, my data is 5 terabytes. I'm not gonna. That would be expensive. And what you're thinking about when you think about 5 terabytes is your total data set. But if you think about what you're actually exposing to your internal customers or users from that 5 terabytes, it's usually a big reduction. And so that's where Materialize is able to work all in memory, because it really is throwing away everything it doesn't need to answer the queries that you've created. And so even if you have a very large data set, you're able to maintain the indexes and the views for it in memory.
Well, thank you so much for all of those answers. Really appreciate you sticking around to answer a few questions. There are a few more questions in the live stream, so if you're free to hang around for a bit and answer them online, that would be awesome. But
I'll do that.
Really appreciate your time. Thanks so much, Andy.
Thanks all.
Awesome. Cool. All right. So up next, we have our second speaker, which is Brett Randall. He is a senior solutions engineer at Confluent. So obviously the Kafka part in the previous presentation, although they were mentioning Redpanda, but Brett's here to take us through not so much, I'm sure he'll tie it back to Confluent, but he's going to actually take us through data mesh and a bit of an intro 101 to it, and how we can perhaps look at implementing it in our own companies. I'm sure you've had a lot of experience doing all of just that with some of the customers that you work with. Brett, you work with quite a few customers in and around the financial services space, is it?
That's right. Yeah, that's right, Peter. Insurance companies, financial services, the big banks, but also in terms of media and retail, and all the way down to the edge with power companies, utility companies, and so on.
Yeah, awesome. Well, I might let you take it away, because I'm sure you don't need me distracting you. And thank you so much for...
No worries. Thank you. And I was going to just say that it's a really exciting time to be talking about data mesh and some of the principles around it. I've been at Confluent for 2.5 years, a little over 2.5 years. And during that time, there's been a real subtle change, I think, in the conversations around how people are building out architectures and how people are looking at data engineering in particular. So I just wanted to share some of those today. I was thinking of actually doing like a slide free. I try to do one slide free day every time. So maybe we'll do some drawings first. I was sketching out my ideas around this last night, and I was putting down the data mesh principles. So I'll walk through these pictures. As I drew them, I realized that I'd drawn them in portrait form, not landscape. So you'll just have to forgive me. They don't kind of present perfectly on the landscape mode. And it's hard to get a feel in these virtual meetings of how many people have seen a presentation on data mesh and understand the principles. But I'm just going to run through those principles and what they mean in terms of the way that companies are thinking about engineering their data and their data architectures. And it really, for me, if you to take one takeaway, I guess, from data mesh, it's really that the companies that I'm working with that are talking about it or are talking about similar kind of concepts, they really are looking to just elevate data to a first-class citizen in their architectures. And there's been so much discipline around software design. We have so many years of kind of practice and patterns and so on. And so in a way, data mesh is really trying to apply that kind of, we've got to microservices in terms of, the certain service meshes and so forth in terms of software architecture. But what can we do with data, and how do we elevate data to being that first-class citizen within these organizations? And it really comes down to these four principles. It was first proposed by Zhamak Dehghani from ThoughtWorks. She's proposed these four principles that kind of formulate a kind of framework for talking about building a data mesh. And again, for me, it's just taking that data and putting it as a kind of a first-class citizen. And then after I go through these principles, and I'll jump over into Confluent Cloud and show you how in Kafka we work with data streams to try and implement this data mesh as basically a continual series of business events that need to be processed. And I enjoyed Andy's talk, and I saw there was a comment there about SQL being, isn't that a fax machine? So you'll probably get a little chuckle later on, because I'll be doing some SQL as well as like a DSL to access some of this data from the stream. But let's go through the four principles for starters. And data mesh principle number one is really about trying to harness. We know that domain-driven ownership and domain-driven design is a good thing, right, in terms of building data. It's one of the patterns that's emerged as a real success model for how do we get the most out of our teams that are designing and working with applications and data systems. So this really just means the people who are publishing data and sharing data into the data mesh really ought to be the ones that understand the data. So it's a decentralization model of data ownership. And I don't want to go and kind of diss data warehouses, and data warehouses have brought us a lot of value, but one of the anti-patterns that has sometimes emerged in terms of implementing a data warehouse is, this basically a centralized model of ownership where data gets dumped in there, and then you can probably imagine, who's this poor person over here? They're probably the data warehouse administrator that has to understand everything and has to help everyone out and try and clean up the data and run all the cleansing and so on. So this kind of centralized ownership model has been shown to have issues. So data mesh principle number one moves us really towards this domain-driven model. So we now have teams and domains of data, teams that own and understand that data, and then they share that data into the data mesh. Now, I've subtly put a tube there across the screen, basically a stream of events, basically. And it doesn't mean that has to be the way that a data mesh is implemented. Streaming events and event streaming architectures is a very common way and is sort of emerging as one of those patterns as what way people are implementing data meshes. But the data mesh itself is technology agnostic. It's just these four principles that apply in terms of building this stuff out. So that's really principle number one. It's pretty straightforward. Have these teams that are working with the data be the ones that publish that data into the data mesh and publish it in a way that can be easily consumed by other teams. And then as we go through the other principles, you'll see how that plays out in terms of what those teams are actually doing that are in those domains. So data mesh principle number two is data as a product. And yeah, this kind of transcends the idea of microservices as a product and applications as a product, and saying that when we bring it down to the actual data that's underlying these services, it's really a product as well, right? And we need to treat it as a product. And it's not to say that we don't already do kind of schema designs and very careful designs about how data is laid out, how it goes into a database, and so on. But data as a product really takes it to the next level in terms of, can I log a bug against this data product? Yeah, how do I communicate? And a lot of these data mesh principles really are organizational affecting. They're again, technology agnostic, although technology will help solve some of the problems, but they really are at the core of how do we organize ourselves into teams, and how do we improve incrementally and basically build out this data mesh as something that's going to be a data mart that's very useful for other teams to immediately adopt and get access to the data as they need it. So this means that it could also include some encapsulation. I haven't drawn this out here, but really the data not only includes schema and metadata and code. So basically being able to bundle together a data product with things like code that might operate on that data. So a series of libraries that would make interaction with that data quick and valuable and error-free, really not reinventing the wheel, that sort of thing. And also infrastructure. So how is this data shared? What infrastructure is it deployed on? How do I replicate it? Does it need to be available in different security zones and domains? Does it need to be replicated to different regions globally? And at what kind of latency is that required? And so on, and things like data governance and data sovereignty. So there's many analogies here to microservices, like the way that we would treat and build a microservice, and basically saying that data is a first-class product. And it brings up some questions, about how is data moved and how are data products composed. So data products can, borrow from other data products. They can consume upstream feeds and provide an enriched product. You can see there's a nice shadow of me taking a photo of my diagram. So moving on to data mesh principle number 3. This is a really important one, right? This is where we start the rubber hits the road in terms of making this a valuable commodity, the data mesh. And that's the self-service data platform. And so there's a number of inputs that are required to this, and I'll show you in a moment how some of these are starting to build out and what enterprises and customers are demanding in terms of these kind of elements in the data mesh. And that's things like a catalog. So the catalog of data, being able to find the elements of data that you need to consume and to build your application or to build your event-driven microservice. Information about the metadata. So is this data current? If it's obviously if it's a stream feed, then it's going to be event-driven and it'll be very current. But things about security and how this data can be shared, whether the data is encrypted, and so on. And then information about the quality of the data. And this is another kind of attribute that starts to come into the data mesh, is what's the service level agreement on this data? How do I get fixes? If I'm going to use this data, am I allowed to send it to other places? These kinds of quality and metadata features. And one of the things I've written here really is something that was touched on in the previous call as well, and this is like Lambda versus Kappa architectures. So I'm not going to dive into the very detailed discussion around these different type of architectures, but one of the things you'll find that comes up as a barrier to building out complex products based on many data flows, and when you need many data sources to build something, is this idea of, do I need to combine together, batch data and old baseline data, a snapshot of data that's very large, with a real-time feed, so something that's actually now and current, and how do I do that? And so there's sort of the previous generation of applications and architectures around this are really around the Lambda architecture, which is really trying to build kind of a view of combining together a baseline view and extract with a live feed of events. The Kappa architecture moves to a point where you should be able to do that with a single feed of all of the events. So this is where, having Kafka and the distributed log and being able to store very large amounts of data for long periods of time, and then being able to rewind and reread that data. And if you can, compacted topics was mentioned before as well, you can really start to use that stream as the source of truth, right, for certain types of data feeds within your organization. Then things come into it like data lineage. So understanding what was the origin of that data, where did it come from, what were the sources of the data, and what's manipulated that data since it came from its very origin. So normally an event will have some sort of origin where it's first detected and brought into the organization. It could be a customer contact with some system. It could be some sort of a feed that comes in externally. And then what's been done to that? So can we track and trace what kinds of joins or filters or projections, data changes have occurred on that feed as it goes through? And this again gives the confidence in being able to use this data mesh as a catalog to build applications on top of. And then the final one is, well, how do I access it? So when we start to talk about the data mesh, it's really about that data and what is my access point to that? How do I consume it? And is it something where I'm firing an API, whether it's a synchronous or asynchronous API calls, or whether I'm able to consume that data as and when it occurs at a speed that I'm able to. So whatever my service is doing, it might be a batch-driven service that only runs once a day, but it could still, consume all those records in a stream and indeed replay that if they needed to be reprocessed for some reason. So just being able to process data and have convenient API access to that. And then these are actually getting harder as we go along. So you'll sort of, I guess, pick that as you apply these principles. There's going to be a bit of a journey here, and data mesh is not something you just kind of build and it just arrives. It's really about incrementally starting to apply some of these principles with an underlying framework of, an end in mind as to what kind of data framework that you want to arrive at. So kind of like the hardest one is sort of this idea of federated governance. And the reason is because it's a real balancing act between centralized governance and decentralized governance. And you need to have kind of like a mixture of both. You need to be able to take very important features in governance, such as data security and so on, and be able to control those centrally where required, but also give the teams the freedom to design some of their own rules around their own data products and set those rules and then incorporate those into the data mesh. So some of the things that come up then is, well, how do I, in terms of governance, how do I handle the semantics or the language of the data mesh? So what I've tried to represent here is, well, is a customer ID, is this field name, this common dictionary of terminology, is it the same as customer ID somewhere else, right? So trying to have that common schema and common naming so that the data mesh becomes more usable because you're talking about the same elements. And then things like error handling. So there'll always be, messages that can't be consumed, and we can use strategies such as dead letter queues and those sorts of things to try and help us process those messages. But really just how can you design your applications to be tolerant of errors in the feeds of the data they're receiving? So could they be perhaps, idempotent in some way, or be able to rewind and replay as required if there's data errors or if there's error in the application and needs to reprocess those messages. So what I might do next, if I can, is just switch over to Confluent Cloud, just to give you an idea of some of the things that we're seeing in the market and with customers, and some of the things that are being built in terms of taking these data feeds. And this is really about building streaming ETL feeds. So what you're looking at here is Confluent Cloud, which is Kafka made cloud native and available in AWS, GCP, and Azure. So I've got two clusters running here. These can be spun up through a demonstration script, so you'd be able to run these up yourself with a Confluent Cloud account. This cluster on the left here is running in Azure in Sydney, in Australia East. And it's a basic cluster, so it has a 0 hourly rate. So it's not costing any hourly rate to run, just for data ingress and egress and storage. And the cluster on the right is a dedicated cluster, and it's running in AWS, but in London. And this dedicated cluster here is, in fact, empty at the moment, so it doesn't have any topics in it at all. And I'm going to use that one in a minute just to show you a couple of things. But like the previous discussion with Andy, you need a way of accessing these streams, right? You need to be able to manipulate and build up this data mesh. And really, I look at it sometimes in terms of refactoring some of your data processing and pushing it down into the data stream and into the data mesh itself. So we have a language called KSQLDB and a database, which is a streaming database. So it's a database that's optimized for streaming queries. So the data from this is coming from Kafka topics. So over in here, I've got my Kafka topics, and I've got a bunch of these that have been set up. Some of them we're going to see used in a moment, which will be things like users, transactions, and credit cards. So I brought these in as Kafka topics, and I've built some streams on top of them so that I can query them in KSQLDB. Now, one of the things I want to jump to straight away is just to give you an idea of how this relates to a stream workflow. So this diagram here is one that you don't draw in Confluent Cloud. It's drawn for you based on the instrumentation of what's running in there in Confluent Cloud in these clusters. And it's showing us the flow of data from left to right. So data is coming in through some connectors that we see here that are managed in the environment. These are going into topics, and then you can see that we have joins. So these are actually joining together and enriching the data from a stream with the data from a topic joined on a common key. So I'll just show that and just show you what the KSQLDB interface looks like. So in here, I've got my persistent queries. So these are queries that are running permanently and generating new streams and enriching the data. I've got a list of these. And again, they're basically a familiar SQL language. And then we have some tables. So these are entities that have a key, and as we feed in new updated records into them, they will automatically compact down on that key. So we're basically seeing in any of these tables the latest record from those entities as they come from maybe a CDC system. So where's this data coming from? Basically got data integration in here built into Confluent Cloud. And this is where you start building your ETL pipeline by deploying these managed connectors, where I can say, if I want to get some data from MongoDB as a source, I can click through on one of these tabs, and it will walk me through a wizard interface to deploy that connector and run the compute for me. So it's like a serverless service effectively to bring that data in. So any data then that changes in MongoDB, I can capture that as an event and take the document that was updated and place it into a Kafka topic, and then I can have my event-driven service consume that. But what if I want to be able to query those ad hoc, or I want to be able to kind of enrich that? We've got this editor here where I can sort of, a context-aware editor, so I can start sort of building out a query based on what tables and streams I have. Now I want to read this transaction stream. Now this bit of syntax at the end here, not standard SQL, right? And this is because KSQLDB has two types of queries. It has a push query where it's basically processing the stream. Okay, it's a streaming database. It's always reading new events and basically computing those and doing the enrichment, the joins, aggregations, all of those operations, and then sending you the results. So the other type of query is a pull query, where I can actually pull the state from the database and actually read a pre-computed aggregate or result from the database. So as you can see here that now I've run this query, I've got results coming through. So these are just the raw results from the transaction table, and there's a couple of like foreign keys you'd probably recognize in there. So what I can do next is, and I've already got this query running as a persistent query, so I can actually query this as a table, but let me just run this now. So this is now doing a join. It's doing two joins, in fact, two left joins. So all of the kind of operations that you would find common in SQL, so being able to do left joins, outer joins, and so on, they're all available as kind of SQL joins in this editor as well. So now I'm seeing an enriched record stream. So I've been able to combine together those three streams of data into one kind of aggregated record, which has now got some additional data I can filter from in it. And you can do, quite a bit with this. So in terms of like streaming analytics or being able to build out valuable insights. If I run a query like this, let's have a look at this query for a moment. This is now a query that's got a count in it and a having clause. And I'm looking to build a view called busy stores, for example, where I'm saying I've got a window, a transaction window of 10 seconds. And if I see more than 2 transactions, I'm going to call that a busy store. So I can keep on building out these kind of stream processing, being able to route different kind of priorities of events or different kinds of measurements and analytics to different topics, and then consumers can consume those. So these are all going back into Kafka topics. So you've got that consistent query interface. Now, if I wanted to do an ad hoc query, similarly, I could just go to the command line, and let's say I'm in a client that uses REST. So I'm just going to send here a query that is just an ad hoc query, but here I've said region 5. So the previous query was looking at region 9, and you can see now the results are streaming back to me. So if I had a client that needed to do an ad hoc query of a stream and get a constant stream of results back, then those results are going to be fed back to that client. The last thing I want to cover, just got a couple of minutes left, is really about the data mesh and remote kind of moving data around, right? So in here we see we've got environments, and we've got this thing called cluster linking, right? There's no links defined there at the moment, but I'm just going to very, very quickly create one and show you the syntax that I would do that with. So what this is actually going to do is it's going to create a cluster link between my Azure cluster that I showed you before and my AWS cluster in London, right? So it's able to create this, and it's able to synchronize this data, in an asynchronous fashion. It's not going to slow down production in the local database, but will always be eventually consistent, right? We'll keep up asynchronously. So now I'm just going to run a command to create a mirror topic. So this is now taking a pre-filtered topic, which is this TCU region 9, which is already filtered down to that region equals 9 in the stream. So now if I just jump back to my interface, do a bit of refreshing, should be able to take you to a view in here. Go and look at this cluster here. And where I had no topics in here before, I've now got this TCU region 9. And I could actually look at the messages. They're going to be probably encoded in Avro, so we might actually see some control characters and things like that, but I could build a stream on top of that and read it back. But what's going to be happening here is as each record is produced over in the other cluster, we're now getting a live feed in a different region. So I've been able to move that data, but an actual subset of that data into a different cloud provider in a different region, but it's still in a Kafka topic. So looking at the time, I might stop there and leave it open for questions.
Nice. All right. Well, that was a fantastic presentation, Brett. I liked when I heard the term serverless in used with some of your connectors. I think it was the MongoDB sync or whatever. So and I think that's kind of becoming a bit of a core offering for Confluent these days, where you can just kind of offload all of that management of connectors and managing Kafka itself onto Confluent Cloud, isn't it?
Yeah, very much so. Connectors, KSQLDB, and replication now. So in the past, you would have had to deploy some components and manage them yourself to replicate data between clusters. Now you can just do it just by linking those clusters together.
Sounds music to my ears, as like someone who's pretty passionate about serverless and not wasting unnecessary effort on managing infrastructure that is already a solved problem that That sounds
Yeah.
amazing. We had a couple of chaps mention that they're going through the data mesh journey themselves, which is really cool. I really loved the diagram, the lineage diagram, of
Right.
all of your sort of connectors and syncs and from the various topics and things like that. I know there's a thing called the Kafka Schema Registry, but do you have some sort of mechanism on Confluent Cloud to sort of collect the different events and automatically generate schemas?
Yeah, it's a great question. Those schemas are automatically generated from those data source connectors. So these ones that are running at the moment are generating dummy data. But a really good idea is, what if I was looking for someone, like if we have a field called gender somewhere in the system, and I can find that. So there's a catalog here, which is part of the data mesh idea, right? So I can now go to that and it takes me to where that field is in my schema. This schema is a protobuf schema, and then I can change between sort of source mode and view mode and actually go in and say, okay, now here's this gender field. I can now tag it as PII. So it's part of this catalog and metadata story. And now when I'm stream processing that field, I know that it's PII and I might treat it differently.
Yep. So, and does Confluent, like, say, if I wanted to pull out all of that data out of Confluent and into, my bespoke data catalog or something like that, you've got APIs to fetch that data?
Yeah, absolutely. There's REST APIs everywhere. So the schema registry is a REST API, and you can also make REST API calls to pull out that lineage view.
Sounds amazing. Abhinav has asked a question on that note. Can Kafka notify another service when the rate of input on a topic increases?
Yes, that's a great question. So, I mean, that's what you saw here earlier, and I don't have it running on my screen, although I could probably bring it up rather quickly if I had time. But there's a lot of metrics here, right? So you're able to measure things like consumer lag. These are the key metrics when building microservices across topics, so that you know whether a service is falling behind or has stopped indeed. But I have actually used something like Grafana, and we have a metrics API that's available to pull data out in Prometheus format. So there's a native Prometheus open telemetry endpoint to get this data back. And then you'd be able to write alerts and say, well, if the topic produce goes out of bounds, then you would get an alert.
Awesome. Sounds great. Another question from JT. He's asked, how do you find, it's a data mesh question, how do you find that balance between to promote domain ownership with visibility for governance?
Yeah, I think that's the tricky balance, right? Is that you'll often have, office of the data kind of teams within an organization that's putting that governance layer on top of everything and kind of trying to hold things back or make sure that things stay in check. But you want to give that freedom out to the teams as well to kind of innovate and advance. So it is the hardest area, that applying that data governance, and it really just requires bringing those teams together and agreeing on what matters and what the hard and fast rules are, and then allowing those teams to also have their own kind of rules as well, and just merging those together. Here's a Grafana dashboard that's actually running against Confluent Cloud. So it's quite show you that you can actually monitor everything in terms of data that's coming in and out and set alerts on it.
Sounds awesome. Well, that's been a fantastic presentation today. Abhinav just said thanks for your answer. So job well done on your question answering there, Brett. So see you next time. Awesome. So up next, we have our final speaker for today. Will Zhu. I hope I'm pronouncing his name correctly. He's product at Imply. He's got an incredibly impressive CV, having worked at Facebook on externally visible metrics as the first product owner for Hive, HBase, and Phoenix at Hortonworks, as well as product manager at Datadog. So an extremely experienced resume. Very excited to have him with us today. But here he's actually going to be, that all sounds like super complex, but he's actually going to be taking us through data analytics made easy. So I'm very interested to find out. building a Twitter scale modern analytics application, bit of a tongue twister, in under 10 minutes. So that sounds fascinating. You've got some slides for us, which you're about to full screen, nearly. And can't hear you, Will. I think you're on mute. So still on.
Sometimes.
Yeah, we got you now.
Awesome. Okay.
So you're dialing in from the Bay Area?
I am in Toronto tonight. I'm here with my family. I'm going to be in Toronto for a while, and it's snowing outside. It's pretty beautiful. So very nice to meet you guys.
Awesome. Well, I might leave you to it because I'm sure it's getting pretty late over there. So thanks so much for staying up and being with us today. Cheers.
Yeah, absolutely. Yeah. First of all, thanks, Peter, for having me. I really enjoyed the presentation from both Andy and Brett earlier today. I think Materialize in itself is a very exciting technology platform. I personally don't even think us as like a competitor to Materialize, but to a large degree, I feel they are really enabling a lot of people to simplify sort of the workflow of building real-time applications. So is Confluent. You know, we are in partnership with Confluent, and a lot of the stuff that we're building depends on the existence of Kafka and real-time streaming data analytics. So I'm really grateful for the folks who has worked very hard on making this technology available and scalable. So I think in general, like my past experience sort of tells me that the data community is a very small, very well meshed together like community, and we're sort of like more or less all in this together. And I think we all be working with each other together on this. So really, you know, again, thank you, Peter, for hosting the session, and also thank a lot for Andy and Brett for bringing in all the exciting stuff from Confluent and from Materialize. What I'm going to talk about today is I'm really going to start this talk about real-time analytics is a do or die today. I built the slides specifically for everyone who needs to convince their management or who needs to convince their business ownership it's essential for them to invest into real-time analytics. It's not about the product I am like representing, right? It's just like in this area in general is today in this world, you need this kind of technology to enable you to even stay competitive in the market. Uber, Lyft, Airbnb, Amazon, every single one of them relies on the ability of having real-time analytics available for them to conduct their business. So if you as a business do not have this kind of capability or you don't have this kind of technology, it's going to be really challenging for you to stay in the market. So the product I'm representing in the open source world is called Apache Do It. At one point in the past, I used to work for Facebook. Facebook runs all the real-time analytics on this engine called Scuba. Very similarly, on Google, there is an engine called Porkella. And what if you are not Google or if you're not Facebook, if your focus is not ad tech? Well, Druid is your answer. That means companies like Lyft, company like Pinterest, company like Twitter, they're all depending on Druid. It's really the engine that powers sort of this data sync for doing real-time analytics. The reason that I keep telling people this is one of those technologies I'm super excited for myself, right? Personally, is because it's just so much faster than any other engines that I've ever built in the past. I've worked on Hive, I've worked on Phoenix, I've worked on HBase. None of those engines come even too close to Druid's performance capability in terms of once you hit like a certain scale. Obviously, if you have like, 50 gig of data, sure, optimize Postgres, you'll be happy, or MongoDB, you'll be pretty happy. But once you hit like a certain scale, you want to do analytical workload, you're like, oh, I want to plot some charts, I want to see usage numbers, Druid is your friend. So there's a lot of companies out there, right, as I speak. If you're not Google, if you're not Facebook, this is sort of your engine of choice when you want to do real-time analytics. This means, Netflix right now, most of their infrastructure monitoring stuff runs against Druid. Lyft, a lot of their dynamic pricing stuff runs against Druid. In this category here, you will see ad tech companies like Reddit or retail companies like Walmart. They run their use cases on top of Druid. And on the very, very far end, you see companies like Twitter, which is one of the largest scale Druid deployments out there. They have more than 1,000 nodes. And then they're also scaling up. And funny enough, right, as I said, everyone's in this together. Even Confluent as a company, Confluent Cloud itself, sort of leveraged Druid within their infrastructure, and vice versa, right? We also use a lot of Confluent Cloud infrastructure within our product offering. So the stuff I want to talk about today is really, Druid is a database in itself. It's very fast. It's like a Formula One race car, right? It can go down the racetrack, no problem. You can win the race, but it requires tremendous amount of engineering effort, a lot of deep understanding of data, and a lot of effort on building up a data infrastructure to make this database function well. The analogy I sort of talk to people is, what you're really building is a chocolate cake with a cherry on top. There's a lot of work you have to do for any kind of application you're doing before you get to the cherry. And what we are really here to do today is really about building up this whole chocolate for you. So this means with Implies data offering that we have for Druid, on top of Druid, there is a manager system that does the deployment, upgrade, patching. There is a building Kafka streaming system. Right now we're partnering with Confluent Cloud. There is the engine itself. It's a really, really fast database engine. There's a built-in BI visualization layer. And then lastly, there is a metric data collection layer. So what this means is the product we're building not only is this fast database engine, but also everything surrounds it. And then hopefully you as an engineer or developer, if you're making a data application, you don't have to worry about building any part of this system. And you can just very, very easily putting together applications, start executing it. So I think that's enough context, enough talk. And I highly encourage you to ask questions you might have, or any kind of comments or feedback in the YouTube channel, and then I'll take a look once I get to the YouTube channel. What I'm going to do right now is to show you guys a very short and quick demo of starting and building application under 10 minutes. With implied data, what you can do is there's a trial available on the site. It's available for you today. All you need to do is just go to imply.io and sign up. It's as simple as that. We do not ask for a credit card, no payment information, right? You just put in your name, email address, so that I can get in touch with you if something goes wrong, and you can sign up for it. It's very, very simple, very straightforward. Once you set it up, it will look something like this. Basically, what you do is you land into an environment, and then it has documentation. It has a basic home dashboard that guides you through the initial data loading and data creation experience. Now, the important thing to note here is you're like, yeah, I can do this with Google Sheet, right? I can do this with any other kind of BI application. What really makes this product and software different is if your application ever grows, or if your usage ever grows, to scale this up, it's as simple as just picking a bigger size. Remember, this is a product that's able to scale to 1,000 machines, right? So this is one of those products that's capable of scaling to Twitter scale. If your app is, or your use case is so exciting and so many people are using it, you're generating as much data as Twitter, great, right? That's awesome news. And we really want to help you get to there. The underlying thing is this is a thing that you can very easily build on top of and very easily scale up to a very, very large scale. And in here, what you will do is you go into the data table. You can say, hey, I want to create a table. I have this like already created, right? It's very, very simple. You have a timestamp, you have a metric name, you have a value, and I can do some like schema editing. I can add in a few columns I want. What I will do here is, this is a very, very straightforward thing that you see here. This is like a postman. I'm just sending a post request to an API endpoint that contains this table's name. That's it. Remember, you have no Kafka, you have no HTTP collector, you have no infrastructure, right? This is like purely software as a service. And all I need to do is just send in this metric. Oh, sorry, I think my token just expired. Let me get a new token. Like any software demo, let me see if I can get this one to be sent. Okay, great. And what you'll see is, on the other hand, this metric shows up immediately. Everything is streamed live, right? So if I change this number to, say, 13 and then give it a different timestamp, and I send it, will show up here immediately. Everything is streamed live into the data table. Again, this thing will automatically scale itself, right, to essentially like a 1,000 server. If your application or if your business becomes that successful, you basically don't have to do anything. And from here, what you can do is you can come back here, you can go into a data set that you have already loaded. You can build dashboard very, very easily. For a lot of data warehousing and data analytics applications, you have to purchase sort of like a separate software like Tableau, or you have to set up your own BI layer like Superset, for example. With Implied, this is all fully built in. This portion of the UI is also open source. It's called Implied Pivot, and you can customize to your heart's desire. From here, what I have is I have a flight information. This is like a rail data set. What I can do is I can pull in the destination geo, basically tells you where the destination are. And let me figure out how fast are or how late the flights are arriving. And it's very, very easy for me to put in and to say, okay, there's like a geography. This is the geo hash. What if I pull in the city for this airport? What is the destination city for this airport? Oh, it's very clear, right? Fort Lauderdale. This is like one of the airport that's having a lot of traffic problems in Florida in the latest day. So as you can see, this is like super, super straightforward, right? It feels like a very, very small scale app. It's really straightforward. You can just open this up, push in some JSON blob, as I've like shown here. Oh, where's the JSON blob? Yeah, here's the JSON blob. Pull in some JSON blob with the timestamp, with some metric name, some data, and be able to start like visualizing it, all built into the same application. And as you scale, if you go to a few terabytes or even like a petabytes, right? This is one of those solutions that can easily scale with you, because we have proven this will work at really large scale. All right, so that's the extent of my content, and I actually want to open this up for some discussions or any kind of questions for folks on the stream if there's any questions.
Awesome. Well, thank you so much, Will. That was a really great talk. And we do actually have one question from Abhinav. He's been really on fire on the live stream today. He's asked, can you provide some more details on the metadata store, especially pub sub latency and security?
Yeah, so is that a problem directed towards me, or that's like a problem directed towards Brett around Confluent Cloud?
Oh, okay, yeah, sure. So, I mean, I guess in terms of where Imply begins and ends, getting the data into imply that's kind of more of a concern for, say, your Kafka stream provider and the security around that. What sort of could you talk specifically to the security story of how do you encrypt data all the way through from, say, a self-managed Kafka cluster topic all the way through to imply? Is that a story that?
Yeah, I think that's a great question. There's like two things to unpack here. One is around like encryption. Everything that we do is following sort of like industry standard, right? Everything is like TLS encrypted. You have to give us a cert that you truly trust, right? We have to get your like credential, and then you have to essentially work with us to enable a private link if you really care about like sort of like the layer 2 security kind of thing in your network, right? So all those things are things that you can like work through with and imply today. Now, if you're specifically talking about Confluent like schema registry or like any kind of Kafka stream registry, all those systems, depending on whether you're hosting your own or using Confluent Cloud, they have different authentication mechanisms. And we will give you the ability to basically plug into any kind of like, well, not any kind. I think like I'm extrapolating that quite a bit. But for the most part, we support Confluent Schema Registry. If you have like a standard open source stuff on Kafka side, we can also support you. Either you're doing HTTP basic, you're doing SASL, or you're doing like cert-based auth. Kerberos, you should probably not do it anymore, but if you like truly desire, you're in that camp, talk to us. We'll figure out a way for you.
Sounds awesome, and we definitely appreciate the flexibility on that front. Abhinav's also asked a question around attribute-based access control. Is that something that Imply supports?
Yeah, Imply or Druid as engine that supports like RBAC. So it doesn't really have like ABAC. ABAC to a large degree, when we talk about it, is like you have different tags for different resources, and that there's like a sort of a mixed policy for like access control, where that actually hinders performance when you get to like a really large scale. Unfortunately, like security and performance is always a thing that competes with each other. Was implied the route we're going after. And if you look at Materialize, if you look at like Confluent, a lot of those runtime vendors, today we're going towards sort of not the maximum flexibility, but more like we're optimizing for the most like performance. What that means is we're going to like a limited, more limited sort of like a permission scheme, which is like RBAC, right? So you're really doing like a user of a row, and sort of like it's always hierarchical instead of doing like arbitrary tag-based like resource control. So in that way, yes, Imply supports RBAC, and so is like every single other vendor like in this space. We sort of like all talk to each other.
Yeah, I guess it's just just understanding where Imply fits in that piece of the puzzle. You might not put all of your super top secret data into Imply because it's more of a super hot store that you want incredibly sort of fast sort of response times and things like that, and data available at lightning speeds and able to be crunched really quickly, as opposed to say that top secret HR data set or something like that. I don't know if that example makes sense.
Yeah, that example makes perfect sense. What I always tell people is Imply or Apache Druid as a database is a place where you should put in the last 4 digits of your credit card number into. You should never put your full credit card number into this database. You should probably use some other secure store system where performance doesn't matter as much to store the full number. Right, but for like analytical purpose, you should start, the last 4 digits, and then that's the perfect store for you.
Yeah, I think that's really useful to know, and I guess, it helps you sort of, really get a good sense of where it fits in the ecosystem and, sort of more application facing and things like that. So that really appreciate your answers there. Um, Abhinav, finally, his last question is, I was wondering if there is a better alternative than joining tables to get A back. I guess, yeah, maybe just use a traditional data warehouse or something like that. Is that kind of the answer?
Yeah, I think like to some degree, like give me some rope here, right? Because I worked on a few other like database tool engine as well. I think the best way, as you described it, is depending on how risky your data is. If it's like truly super risky, if anything leaks, you will be in really deep trouble. Maybe not even joining is sufficient. Like you should, in that case, probably have like complete network access permission isolation. And what we have seen, what our customers do is, for some, they're like super sensitive data. They will even have essentially like physically walled off section of the Amazon Cloud Data Center where their data is being stored. What I'm talking about is like physically there's a concrete wall, right, within the data center where your data is on the other side. So it really depends on like your level of like risk tolerance. So if you're like your data is so sensitive, you're like any leakage of data is going to cause serious trouble for your business. Doing join is probably even like a bad idea. You should probably just like physically separate your data to somewhere else.
Yeah. So it's great to get that context. So and hopefully, I'm sure there's some local contacts, Abhinav, with Imply, so and Apache Druid. So if you wanted to dive a bit deeper into those discussions, I'm sure that those conversations can be had. But yeah, I think really looking forward to dive a little bit deeper into Imply. Maybe I need to create myself a nice real-time dashboard about sort of our tech community that we're growing here in Sydney. Perhaps we can do something with Imply at DataEng Hack. Who knows?
Oh yeah, absolutely. We'll see. Right.
Yeah. Sounds good. Well, really appreciate your time today, Will. Thanks for coming down, and I know you're a busy man, so appreciate it.
Thank you so much for having me here.
Thank you. Cool. So that's it for the meetup this month. We've had 3 fantastic talks from 3 fantastic speakers. Obviously, next week we've got an in-person meetup here in Sydney. Planning in-person meetups as well. There's going to be announcements about one in Melbourne and another one in Brisbane in the not too distant future. So, feel free to put your hand up if you've got something interesting to talk about. We heard from 3 vendors today. I always really love hearing from data engineering practitioners. I think that some of those talks can be fascinating to hear when the rubber really hits the road. So yeah, if you've got something that you're excited to share about, talk about, then definitely do reach out. DataEng Hack, get those tickets. There's even less than 50 available now. They're selling fast. I don't want anyone disappointed. So please do secure them, because there's going to be some amazing technology and technologists on display. And, from personal experience in attending some of these events, they can be truly career changing. I wouldn't go as far as life changing, but definitely career changing. There's a lot of opportunities that can come out of these things, and, growing your network and things. So I couldn't encourage you more to get along. But thanks so much. We do plan to keep on rolling out the online data engineering meetup and live streaming in-person meetup. So thanks for joining me on your lunch break today. And yeah, ciao for now. Bye.